Hello, everybody. My name is Stan Manstre. I'm a plastic surgeon working in the University Hospital in Ghent, Belgium, and I have a special interest in the management of burn injuries. I have no disclosures at all. This means that I have no financial or any other connection with any of the products I will be talking about, even if I get pretty enthusiastic about some of them. So, the World Health Organization, WHO, has identified antimicrobial resistance as one of the three most important problems facing human health. The widespread and inappropriate use of antibiotics for humans as well as for domestic animals has led to an increased prevalence of the so-called multi-drug resistant MDR bacteria in the environment. The threat to public health is immediate because MDR infections have been leading to about 700,000 deaths globally already in 2016. It is predicted that by 2050, the death toll could be a staggering 1 person every 3 seconds. So 1 person every 3 seconds if antibiotic multi-resistance is not tackled now. It has long been thought that antibiotics and antiseptics are something completely different. However, the recent literature has shown that the two are definitely linked. And due to the emergence of this multi-drug resistance for antibiotics, the use of antiseptics for skin disinfection had to be re-evaluated. Since I'm a burn surgeon, I always had a specific interest in antisepsis and wound infection management. And already in 2003, our group published an article entitled "The Role of Iodine in Antisepsis and Wound Management, a Reappraisal." Why specific the role of iodine? Because I have to confess that over the past 10 to even 20 years, we have been using in our burn center mostly PVPI or betadine as our major disinfecting agent. And actually, we've been pretty happy about it. And although we've done a lot of evidence-based research in the field of wound management, we haven't been focusing too much on specific research studies related to antisepsis. And for this reason, we have performed a very extensive review entitled "Addressing the Challenges in Antisepsis, Focus on Povidone Iodine." And this review was published actually a couple of months ago by the end of 2020. And this article summarizes about 18 years of specific research on antisepsis and on the role of povidone iodine, especially in relation to other antiseptic agents. The aim of this review article was to discuss the key challenges in antisepsis management today, which consist of about 4 major issues. First of all, antimicrobial efficacy. Second, antiseptic resistance. Third, antibiotic and antiseptic cross-resistant, a new issue. And finally, the effect of antisepsis on wound healing and tolerability. As I already mentioned, the article focused specifically on povidone iodine, but always in comparison with other commonly used antiseptics. So let's go for the first one, the first big challenge, which is antimicrobial efficacy, and also with a focus on the inactivation by organic soil and blood. In an era of growing resistant bacteria, new viruses, as we all know, and microbes, it is obvious that a broad antimicrobial spectrum is needed. And I must say in that 2020 review, we were pleased to notice There is always there is often some controversy in the literature, especially on antimicrobial agents, but we were very pleased to notice that if there is one thing all articles seem to agree upon, it is the fact that PVPI has the broadest antimicrobial spectrum. Indeed, as you can see, povidone iodine is active against gram-positive bacteria, gram-negative bacteria, actinobacteria, but also, maybe the only one, active against spores, also against fungi, and I will come back a couple of times on that, and which has become increasingly important over the past 1.5 to 2 years, also active against viruses. McClure demonstrated that PVPI exhibited a highly significant superior killing effect on MRSA strains, which stands for methicillin-resistant Staphylococcus aureus strains, compared to chlorhexidine, whether measured by rate of kill or by final log reduction factor achieved. And as you can see, all the yellow columns showing the final log reduction factor are related to PVPI and are much higher than chlorhexidine. McClure also showed that PVPI efficiency on MRSA was less affected by dilution compared to chlorhexidine. Indeed, as you can see in the figure to the right, there is a regular decrease of antibacterial activity with chlorhexidine throughout the dilution rate, showing the red line, while for PVPI, the activity is only decreased for a dilution higher than 200. You see the yellow line stays horizontal till the dilution of 200. And the difference between these two treatments is highly significant. It is essential to mention hereby the importance of adding organic soil to the so-called in vitro tests. We should know, or we should realize, that chronic and more so acute wounds always exhibit a certain amount of organic matter and blood, which might interfere with the antimicrobial effect of an antiseptic. Therefore, when applying antiseptics to wound, the potentially inhibiting influence of such organic soil and blood must be considered. It is therefore essential when setting up in vitro tests and testing and comparing liquid and gel-based antimicrobials that a strictly standardized setting should be used. And this is what we now call the new phase 2, step 2 test method. This is a very demanding in vitro test, but it is actually the best test that currently is on the market. It is modified on the basis of very strict European norms. And I don't want to go too much into detail, but it consists of drying the microbial test suspension in a metal carrier for 1 hour, overlaying the test wound antiseptic, washing it off, neutralization, and dispersion at serial dilutions at the end of the required exposure time. So a very demanding test. With these tests, Barreto, in an article, in that recent article, showed that PVPI had the shortest time to efficacy, even in the presence of blood. Indeed, as you can see in the upper bar, the required exposure time to achieve efficacy with and without organic soil was the shortest. You see it first without, then with organic soil mainly consisting of fetal bovine serum, and in the third column with blood as organic soil. And you see the shortest exposure times were achieved with PVPI. A new thing or a new issue that has received increasingly attention over the past years in the literature and also in the clinical situation is the so-called microbiome. Indeed, it has been shown that increased fungal colonization leads to a worsening wound environment, increased bacterial infection, and a subsequent increase in prescribed antibiotics. What I show you here is an example of a wound culture taken by one of our burn patients and showing the presence of Candida auris. And indeed, fungal contamination has been noticed much more frequent in recent years compared to 10 or more years ago, showing the importance of the microbiome. As a logical consequence, we should be convinced that wound care strategies nowadays shall benefit from an application of a broad spectrum topical antimicrobial agent that targets both bacteria and, of course, fungi. Moore showed chlorhexidine aqueous washes are not effective in removing Candida auris from the skin of colonized patients, in contrast to PVPI and chlorhexidine in alcohol, which of course cannot really be used on open wounds. And you see that the reduction in Candida auris and Candida albicans is much lower for chlorhexidine, 2%, compared to the green area with PVPI. This is the same article of Moore entitled Yeasticidal Activity of Chemical Disinfectants and Antiseptics Against Candida auris. And his conclusion is that iodine-based skin antimicrobials were effective against Candida auris, suggesting that their use could reduce environmental contamination and skin colonization, respectively. Then we arrive at the second big challenge for antiseptics, which maybe is the most important one, concerning the resistance issue. I already mentioned at the beginning of my presentation the importance of multi-drug resistance, and this was recently confirmed by a statement of Tom Frieden, who is the director of the Center for Disease Control. He stated that antibiotic resistance is rising for many different pathogens that are threats to health. If we don't act now, our medicine cabinet will be empty and we won't have the antibiotics we need to save lives. I show you here a map of the European Center for Disease Prevention and Control, illustrating the increasing prevalence of methicillin-resistant Staphylococcus aureus in Europe. And as you can see, the incidence is much higher in the more southern countries of Europe compared to the often more strict northern countries of our continent. We all know, and this was already taught to me when I was in medical school, which is of course already some time ago, we all know that there is a clear correlation between the use of topical antibiotics and the development of resistance. And this was clearly shown in a study of Osterlund from the Swedish Institute of Infection Disease and Control concerning almost 90,000 patients. And he showed that an increased use of fusidic acid ointment as a topical antibiotic resulted in an increased appearance of fusidic acid resistant Staphylococcus aureus. When the antibiotic was used less, there was a decrease in the incidence of the resistant strains. This is what is generally known. What is less known is the phenomenon of cross-resistance, which I'll try to explain to you in a rather simple way. On the left side of this slide, you see how chlorhexidine entered or passed through the bacterial membrane, and especially for bacteria who are already developing some resistance, the presence of chlorhexidine might result in an increased expression or an upregulation of genetic material, ultimately resulting in the production of so-called efflux pumps. And these efflux pumps are an innate bacterial defense mechanism against chlorhexidine and triclosan. Why is that? Because those efflux pumps are able, once expressed, these efflux pathways will be able to export antiseptics such as chlorhexidine, but very interestingly, they will also be able to export certain antibiotics, which means that efflux pumps have the ability to give widespread resistance against antiseptics such as chlorhexidine and triclosan, but at the same time render the organism resistance or provide a defense mechanism against certain antibiotics. This was demonstrated by Venter, but this has been confirmed in a clinical study by Wand, who showed cross-resistance between chlorhexidine and colistin. Probably many of you know that many carbapenem-resistant Klebsiella pneumonia isolates are susceptible to a very limited number of antibiotics, one of them being colistin. It is therefore extremely important to secure the efficacy of this antibiotic, but one showed that an adaptation of clinical Klebsiella pneumoniae isolates to increasing chlorhexidine exposure can lead not only to a stable resistance to chlorhexidine, but also cross-resistance to the antibiotic colistin without ever having used the antibiotic. Similarly, Barreto demonstrated that exposing Pseudomonas aeruginosa to an increasing concentration of octanidin over several days could lead to an increased tolerance to octanidin and also to chlorhexidine. This was also confirmed in two clinical studies. The first one by Mendoza in a study of 2014. During a 6-month intervention period, the daily bathing of patients with soap and water was replaced with a no-rinse skin cleansing with 2% chlorhexidine impregnated wipes. And Mendoza clearly demonstrates that body washing with 2% chlorhexidine wipes facilitated the establishment of a more virulent Acinetobacter clone. And with more virulent, we mean a clone with a higher biofilm production and with more resistance. Similarly, Noto performed a somewhat similar study. In intensive care units, he performed a once daily bathing of all patients with clothes impregnated with chlorhexidine and compared this with disposable non-antimicrobial cloths as a control for a 10-week period. And Noto too demonstrated that daily bathing with 2% chlorhexidine didn't reduce the incidence of healthcare associated infections such as central line infections, urinary tract infections, or even pneumonia. The consequence should be that general preference should be given to biocidal agents without or with a very low selection pressure, which means that we should choose antiseptics with no cross-resistance to antibiotics, which are the alcoholic antiseptics, which of course we can't always use in open wounds, but also polyhexanide and even more so PVPI. A new word that is often mentioned hereby is biocidal stewardship. And this refers to the fact that due to the emergence of multi-drug resistance, the use of antiseptics for skin and wound disinfection has been or needed to be evaluated, and that for chlorhexidine, it has shown the need for ethic and responsible choices to avoid cross-resistance to antibiotics. So here, clearly, you see that the relationship is mentioned between, on one hand, the antibiotics and on the other hand, the antiseptics. Let me give you another clinical application of this. Edmiston in 2018 concluded in his study that in an era of antibiotic stewardship with a widespread prevalence of bacterial resistance to multiple antibiotic agents, there has emerged an interest in using intraoperative antiseptic irrigation to reduce microbial contamination in the surgical site before closure and possibly reduce the need for antibiotics. So again, the link between antiseptics and antibiotics. Brown performed a study comparing a total of 1,862 consecutive cases of total hip replacement and total knee replacement performed before the introduction of betadine lavage with almost 700 consecutive cases after the introduction. And he showed that a 3-minute dilute betadine lavage combined with painting of the skin with 10% betadine before surgical closure was associated with a significant reduction in the infection rate after primary knee and primary hip arthroplasty. And you see this clearly shown in the graph to the right side of this slide. As I mentioned at the beginning of my presentation, I am a plastic surgeon, and we implant breast prostheses for breast augmentation, I would say almost on a daily basis. And I can assure you that in my department over the past 20 years, probably no breast prosthesis has been implanted in a newly created bucket without prior povidone iodine irrigation, which has been shown to be superior to antibiotic irrigation. And here you see this mentioned in a very recent study of Deng, who was very much in favor of povidone iodine use in breast implant procedure, given its superior antiseptic property, its excellent safety profile, the lack of resistance, the accessibility, and also the low cost. This might probably be maybe the most important slide of my presentation. It is important to mention that despite the widespread clinical use of PVPI over many decades, there has so far been not one single report of resistance or increased tolerance to PVPI in any laboratory-derived or clinical isolate. So if we want to secure the future of antibiotics, we might have to use more PVPI in a clinical context. This brings us to the third big challenge for antiseptics, which is the biofilm issue. As most of you probably know, bacteria or bacterial cultures are rarely seen in the planktonic or the free-floating situation. Usually, as you can see in this cycle, free-floating bacteria land on an inert or organic surface where they aggregate and attach to the wall, where they start to grow, as you can see under number 3, and divide and start with the biofilm formation. After some time, the mature biofilm is formed, and from there on, part of the biofilm can be dispersed to release, again, free-floating bacteria for further colonization. Biofilm is a heterogeneous structure of different populations of microorganisms, of more organisms surrounded by a matrix, mostly exopolysaccharide. that allow, as I mentioned, their attachment to inert and organic surfaces. Some data about biofilms. Almost 80% of chronic wounds, and certain authors say more than half of acute wounds, are affected by biofilms. Biofilms provide, very important, a protection for bacteria against host defenses and against topical or systemic antimicrobials by reducing the diffusion of these toxic compounds, and even more important, they facilitate the development and the transfer of resistance mechanisms. They are also thought to delay wound healing by eliciting an inappropriate inflammatory response, which is completely ineffective and poorly orchestrated and can damage the host tissues. And I will come back to that later. Staphylococcus and Pseudomonas comprise the most prevalent genera present in microbiota of chronic wounds. I guess most of you are familiar with the two pillars of the biofilm treatment, which are debridement and antisepsis. Debridement, the removal of visible slough and debris, while useful as it might contain superficial biofilm, does not represent the entire biofilm, as much will reside deeper within the wound. This means that repeated debridement is important to suppress biofilm development and keep it in a weakened state, facilitating anti-infection measures. But early presence of biofilm can be detected within 24 hours after debridement. For this reason, debridement must always be used in conjunction with antiseptic dressings and lavage or irrigation to enhance further microbial reduction through killing of microbial cells and to suppress the regrowth of the biofilm. Topical antiseptics that are effective anti-biofilm treatments should have a specific and strong anti-biofilm effect, which is not present for any antiseptics. It is important to have short exposure times, and the antiseptic should also act in vitro tests models against mature biofilms, very important. Johanni, in an article of 2018, clearly demonstrated that at 15-minute exposures, PVPI was the only antiseptic to show complete and efficient killing of both Staphylococcus aureus and Pseudomonas aeruginosa biofilms. You see to the right that both for Staphylococcus and Pseudomonas, there is a very efficient killing. Phillips looked for the effects of negative pressure wound therapy with instillation of first saline, and he compared this to various other antimicrobial solutions, such as PVPI 1%, PVPI 10%, also chlorhexidine and polyhexanide. And he showed that only PVPI 10% showed an effective log reduction of total colony forming units, as you can see here, the largest yellow column. Also, other studies compared the efficacy on antibiotics. First of all, the study of Hill. He compared iodine-based dressings and with some others and showed that iodine-based dressings completely disrupted established 7 days, which means mature in vitro chronic wound biofilms with a mix of Staphylococcus and Pseudomonas, while in contrast, only 2 of the 6 sulfur-containing dressings exhibited any effect on 3-day biofilms, but never on the mature 7-day biofilms. Guimarães, in another study, confirmed that PVPI, compared to chlorhexidine and others, is the only antiseptic that exhibited more than 90% reduction of both Staphylococcus aureus biofilm formation. Oates compared various compounds, tested various compounds on different biofilm communities and showed that the rank of effectiveness was best for PVPI, then followed by polyhexanide, and then followed by silver. As you can see in the red column, the largest reduction in bacterial count was seen for PVPI, 57%, followed by polyhexanide, 44%, and then silver with 27%. I come back to the microbiome because fungi have been shown to be underappreciated agents of complications in chronic wounds, and in biofilms, fungi can indeed provide a scaffold for bacterial attachment and offer additional protection, by that worsening the wound environment. Keane showed that the most effective treatment strategy to eradicate all types of Candida isolates in the biofilm phase was PVPI 10%. And this both for early biofilms, the clear columns, as well as mature biofilms, the black column. He tested this early biofilms, which are 19 minutes, and mature 48 hours biofilms, which were treated each time with an impregnation of 5 minutes with each antiseptic. And this brings us to the recent article of Alves and co-workers entitled An Update on the Role of Antiseptics in the Management of Chronic Wounds with Critical Colonization and/or Biofilm, in which he advocates a paradigm shift in non-healing wound management. And he mentions, or he concludes, that the new objective of chronic wound management is to treat a biofilm-infiltrated chronic wound before it can advance beyond the critical colonization. What comes thereafter is, of course, local and systemic infection, by using repeated debridement associated with effective antiseptics. So the first phase is always the removal of the biofilm, for which he first recommends to perform a mechanical washing, which consists of intensive mechanical washing with scrub. He recommends the betadine scrub to remove debris and biofilm from the wound, and cleansing at each stage of dressing. This should be followed by debridement to disrupt any remaining biofilm, remove necrotic tissue, and stimulate wound healing. This debridement can be performed surgical, mechanical, or even chemical. And this should be followed by a disinfection. And for disinfection, he recommends using gauze impregnated with PVPI dermic solution for at least 1 minute, given the rapid onset of the action of PVPI. And indeed, a fast onset of action of povidone iodine has been demonstrated both in a study of Block, showing the killing kinetics of PVPI to be faster than chlorhexidine and others, and also in a study of McClure, demonstrating that the PVPI efficacy on MRSA is superior and less affected by dilution compared to chlorhexidine. And this brings us to the last challenge for antiseptics, which deals with skin tolerability and the effects on the wound healing process. And I will start by what many people seem to think that still exists, and which is the iodine allergy. And I'm always surprised that still many people quickly think about the allergy of iodine, while in so many articles it has been demonstrated that this is an absolute myth, that there exists no such thing as a iodine allergy. Indeed, it has been clearly demonstrated that the immediate or non-immediate allergic hypersensitivity to iodinated contrast media is not due to iodine, but is only due to the carrier material. So immediate or non-immediate, moreover, immediate or non-immediate allergic hypersensitivity to povidone iodine is extremely rare. And I will come back to that in the next slide. Most important of all, allergic hypersensitivity to iodinated contrast agents does not contraindicate the use of other iodinated drugs or topical antiseptics. The person who really demonstrated the exact incidence of allergy to PVPI and showed that it was overestimated was LaChapelle. In a well-documented study, 500 consecutive patients received or were tested with a patch with 10% povidone iodine solution diluted 10 times in water. The patch test was applied for 2 days, and after 2 days, 14 patients showed a positive patch test to povidone iodine. These 14 patients, povidone iodine solution 10% was applied twice daily on the forearm, and this for 7 consecutive days. And the patients were subjected to the so-called ROAT, which is a repeated open application test. And this is the only real test that can show if indeed the allergy is against PVPI or not. And the ROAT test showed that for only 2 of these 14 patients, it was recorded as positive. So LaChapelle concluded that only 2 of the 500 original patients had a true allergic contact dermatitis from PVPI, which makes the incidence exact to 0.4%. It is surprising, as I mentioned, to notice that so many people seem to know about an allergy or a iodine allergy, and so few people are aware about the serious allergic reactions following the application to the skin of antiseptic chlorhexidine gluconate. And this is clearly mentioned in this drug safety communication of the FDA, which warns for the rare, which warns for the fact that although rare, the number of reports of serious allergic reactions with chlorhexidine has increased over the last several years. It is often said that all antiseptics to a certain degree have an irritant property. And I think this is mainly due to the misuse of antiseptic agents, which means when they are used on damaged or eczematous skin or at too high concentrations. A long time ago, or 10, 20 years ago, irritation and contact allergy were considered as entirely separate entities. Nowadays, it has been shown that there might be some connection between the two related to innate or adaptive immunity. And I will not go into detail on this, but let me mention for this irritacy, sometimes it is said that when you can put it in your eyes, it means it is definitely not irritant and it should be very safe. And this has been demonstrated, first of all, in a study by Was, who showed that the preoperative treatment with PVPI in the conjunctiva before cataract surgery is a safe and effective procedure with no adverse events, and that it is safe and effective to reduce the bacterial load. In another study, Yazar and co-workers showed that PVPI, 3 drops 3 times a day for 2 weeks, is safe and effective with more than 96% recovering compared to 58% with classical treatment in patients with adenoviral conjunctivitis. And this treatment is even used in a pediatric population. Pierre also performed ex vivo test in 33 healthy volunteers to additionally check the irritancy, and he did this with the so-called CIM, or colorimetric index of mildness. And the higher this index is, the less irritancy there is with the product. And he showed that the skin tolerance measured by CIM of PVPI 7.5% scrub and PGC, which stands for Purpose Gentle Cleansing Wash, which is a mild non-antiseptic wash, were significantly higher, so less irritant than chlorhexidine 4% and HDS, which stands for a quaternary ammonium derivate. And you see that indeed the two columns, both of PVPI 7.5% and the PGC wash, are more similar to the column to the right, which is of water. Similarly, Quattrosous performed a study in 30 young adults, and he used the corneoxynometer to assess the irritant capacity of povidone iodine 7%, povidone iodine 10%, and chlorhexidine solutions on 3 skin areas: the back, the forearm, and the forehead. And he also showed that PVPI 10% solution had a significantly lower irritant effect on the skin compared to chlorhexidine 5%. And this is shown in the picture to the right, where you see that the yellow column of povidone iodine comes the closest to the dark blue column of water completely to the left. It is also often mentioned that all antiseptics are cytotoxic. And I think it is important to mention hereby that the in vitro cytotoxicity can be much more pronounced than in a biological system, where a 3-dimensional matrix and a vascular system, and which not necessarily reflects the in vivo or clinical setting. Recent cytotoxicity tests have shown that PVPI has a very low cytotoxicity compared to other antiseptics when tested on skin. Finally, povidone iodine has also been shown to be the only antiseptic that showed remaining cell viability at the minimal bactericidal concentration, which was 1.32 grams per liter. This was also demonstrated in a study of Muller, who showed that PVPI is less cytotoxic for murine fibroblasts compared to 3 other antiseptics, which are chlorhexidine, octenidim, and polyhexanide. Indeed, his cytotoxicity tests have shown that PVPI is better tolerated by those murine fibroblasts more than 20 times versus chlorhexidine, for almost 50 times versus polyhexanide, and also 40 to 50 times compared to octenidim. I think it is important to realize that ideally an antiseptic agent should not only be non-irritant and not cytotoxic, but ideally it should also be supportive for the wound healing mechanisms, for instance, like by impeding excessive inflammation. And this was clearly shown already some time ago by Pierre, who demonstrated in his histology that PVPI enhanced healing of chronic wounds because, as you can see on the left, an inflammatory reaction with focal necrotizing vasculitis was more frequently present when PVPI was not used, as seen on the left, compared to on the right, where it was more absent. This has been confirmed in a clinical study of Fumal. What did he do? He compared the healing of leg ulcers on one hand with hydrocolloids alone, and on the other hand, with hydrocolloids combined with an antimicrobial agent. He compared PVPI with sulfur-silvadiazine and also with chlorhexidine. And he concluded that compared to controls, the time to healing was significantly reduced by 2 to 9 weeks, significant, in PVPI-treated ulcers, which was not the case with the 2 other antimicrobials. Müller also showed that only PVPI showed a revitalization of the cells, which means that they start to grow after antiseptic treatment. And according to him, this might be one of the reasons for a better wound healing and tissue tolerance with PVPI. To summarize what I said about the skin, LaChapelle made a comparison between all the antiseptics and concluded that taking into account all the data available, we can consider that PVPI has the safest antiseptic, is the safest antiseptic in terms of irritancy and allergic profile, with very rare allergic contact dermatitis, almost no anaphylactic reactions or any other problems mentioned here. So the conclusions of the extensive 2020 review, which, as I mentioned, summarizes almost 20 years of antiseptic research and articles on PVPI, compared to chlorhexidine, polyhexanide, and octanidine, povidone iodine seem to have several advantages. It has definitely the broadest spectrum of activity. It is highly effective at eliminating multi-drug resistant pathogens and biofilms. It maintains efficacy in the presence of organic soil and blood. There is a complete lack of resistance or cross-resistance attributed to PVPI, even despite the fact that it has been widely used for decades. It is very well tolerated, with an extremely low prevalence of allergic reactions. And maybe most important of all, there is a promotion of wound healing in leg ulcers that has been demonstrated. So the conclusion of the 2020 review is that with increased understanding of the importance of tackling antimicrobial resistance and bacterial biofilms in acute and chronic wound care, alongside improved understanding of the challenges of antiseptic use, PVPI remains a promising agent for the management of antisepsis. I would like to end with another myth that is often mentioned concerning the use of PVPI, and this myth concerns the color of PVPI, which certain consider as a drawback. Well, let me mention first of all that PVPI never stains a wound. We use it on a daily basis to shower our patients, and we have been able to notice that. But it is important to realize that PVPI is in fact an equilibrium. There is an equilibrium in povidone-bound iodine compared to the free iodine. And it is the free iodine which is the active antimicrobial agent. This means that more free iodine is released from the povidone iodine reservoir or containers as iodine consuming germicidal activity proceeds. And personally, and I'm not the only one, I would rather consider the darker color of PVPI as an advantage, because the color can be used as a visual indicator. Due to the unique brown colored compound of PVPI, we have to realize that when the dressing becomes light yellow or pale, the free iodine is no longer being released. And this means that the dressing should be changed. So the color of PVPI can actually act as a reminder to reapply the product. And with this last slide of the city of Ghent, I would like to end this presentation. Thank you for your attention.